Now we know that these two molecules are identical or are same structure wise, but they have different physical behavior towards plane polarized light. That's why we call them optical isomers. Now, just like we had different configurations and configurational nomenclature for different you can say isomers, same way here also we should have that. We should have different nomenclature for this and this. Now there are two ways of doing this. One is relative nomenclature. We are not going into that. Relative nomenclature is simple. We have to compare it with some reference, and with reference to that it will be given either D nomenclature or L nomenclature, D and L system that is called. We are not going into that. We are bothered about R and S nomenclature. So R and S system, one of them will be called R, another will be called S. This is possible only if they are optical item. This one, the one on the left, this is configuration 1, and the one on the right is configuration 2. So let's keep it here inside in a corner. Let that be our configuration 2. This is configuration 1. Now what I am going to do here is I am going to swap just one of them. I mean two of them. I'll swap just two of them, any two of them, right? And see what happens, right? Let's see that. Let's swap the purple and the yellow one. So this is the purple takes the place of yellow and yellow takes the place of purple. And now we bring this was, remember, this was configuration 1, this was configuration 2. If you see them now, they are not mirror images. They are not mirror images, not possible. But we see one more thing, that now they are identical. They superimpose each other. So if they are superimposing each other, that means what? They are identical. And that means what? This one, which was configuration 1 earlier, is now changed to configuration 2. And what we did in order to achieve that, we just swapped two of them. So obviously if I swap them again, I'll reach to this configuration. But this time I'll swap other two. So let's say I swap this yellow and green one, which I haven't done earlier. So let's swap them, the yellow and the green one. So green one comes here, yellow takes the place of green, and green takes the place of yellow. So now we have this configuration. Remember, this was originally configuration 1. It was changed by one swapping, by doing one swap to configuration 2, and now we have done one more swap, and now we are trying to see what happens to this molecule. So green is on the top, and what do we see now? Now they are not overlappable. They cannot, they won't overlap, right? Reason is that now they are actually mirror images. They are the mirror images, and first they are mirror images. Second, because as you can see, they are mirror images and they have all 4 different valencies, so they won't overlap. So the summary of this exercise is to understand that by swapping any two of them, any two of the groups attached to the central carbon atom, if you swap any two of them, so if this belongs to R configuration, it will change to S. If this belongs to S configuration, this will change to R. And if you do one configuration, R will change to S, S will change to R. If you do one swapping, R will change to S, S will change to R. And if you do swapping again, it will come back to its original configuration. So that means even number of swapping retains the configuration, and odd number of swapping will invert the configuration. from R to S and S to R, right? Odd number of rotations or odd number of swapping will change the configuration, and even number of swapping will retain the configuration. That's all.